Okay, so hello everyone. So we have again gathered here. So this is another presentation of our winter research series. So excited to say, so we have two bright young minds who will be presenting their fascinating work on using artificial intelligence in sensory science, specifically for taste detection. Okay, now over to you guys, Gahan and Nishanth.
Gahan. Yeah. So, hello everyone. My name is Gahan Mukherjee, and I have Nishanth Alampally. And we worked on this project optimizing grape quality assessment using CNN-based deep learning models. So we basically predicted bricks and its grapes, bricks, and grapes type using different kind of CNN models, and we also used different regression models to perform the task. Yeah. Next slide, please. So now we talk about the background of this project. So food without a good taste is considerable inedible. Small mistakes in ratios of flavors can greatly influence the taste of food. So such mistakes can be reduced and prevented using taste detection models. A taste detection model can be used in food industries like wine or sauce production or any ordinary fruit or vegetable pack house. And flavor consists of various elements like sweet, sour, bitter, spicy, umami, and more. Each individual component of taste is caused due to the presence of various chemicals in food and therefore have units of measure. For example, the brix score defines the amount of sucrose or sugar content in a fruit, and the Scoville heat units define the amount of spice of a food. So the goal of our project is to harness the power of convolutional neural networks to predict the taste of foods just from multiple images and later on from RGB images, normal images. So to start with, we worked on these two tasks. First is predicting grape type and then predicting the brix score of the grape and then also using these two factors predict brix using the type of the grape and also the brix of the grape. Next slide. So predicting bricks for wine industries is a labor-intensive and expensive process. Our project explores the application of deep learning to predict grape bricks from images, making it cheaper and less labor-intensive. Our project also explores the relation between visible features of grapes, their texture and their color, and their metadata, such as harvest time, grape type, and the anthocyanin content, which is the water-soluble fruit content. We also performed our experiments with various types of CNN models, stress exception, MSR 3D CNN, ResNet 50, and we also used a different kind of regression models to perform these tasks. So these are some real world applications of the model. So first is wine detection, wine industries. It can be used in wine industries, and then there is V detection, and also production of prediction of plant disease. Yeah. Next slide, please. So why our problem is important and why are we even trying to predict bricks from CNNs? So AI powered taste detection systems are used to develop new recipes, enhance flavor profiles, and ensure product consistency. AI can also analyze an individual's taste preferences and dietary needs to recommend personalized meal plans or products. These models can also predict how a food or beverage will taste before it is even produced. This speeds up the R&D process and helps manufacturers create products that match customer preferences. And AI systems can also suggest foods that are both healthy and enjoyable for each person. Next. So in this slide, we discuss some of the related works that already has been done. So in a study conducted by Al-Samarai and his team in 2022, the authors explored the potential of using AI for the problem of determining the sweetness of oranges by analyzing the correlation between sweetness and the colors red, green, and blue, basically the RGB values of a fruit. As the latter may affect the form in this work, an orange fruit image dataset was used alongside with orange data mining tool and many machine learning methods. The objective was to identify the algorithm that yielded the highest precision. So, for example, another research done by Salim and his team focused on predicting bricks for identification of plant diseases. For example, there is a disease called grapevine blotch disease, which can increase the bricks by 5 degrees or more. So if we can predict the bricks earlier, we can identify the disease and take some measures. Next. So these are some real world application and how we can actually apply our problem in this world. So taste detection models can be used to identify and differentiate between a good produce and raw ingredients and a bad produce. From separating grapes based on their sweetness to tomatoes based on their tanginess, AI for taste detection can have a great impact on improving food production. By expanding the model, like one we worked on, with more physical and chemical features of food like weight, saltiness, tanginess, umami, spice, and more, we can come close, if not exactly predict the taste of a fruit or vegetable with just its images. Here are some. There's a simple diagram demonstrating how we can do it. So first, we can visit fruit or vegetable pack house. We can take the multispectral images of the vegetables and the fruit, and we can also take the RGB images. Then we can measure other features of these fruits and vegetables, their brix score, anthocyanin, pH, etc. And then we can like store these values in NumPy files and perform data augmentation and basically train a model which will basically predict the bricks.
The PPT is not there.
Let me just look into this.
I'll present it if that's fine.
Just give us one.
Just a second, I'm presenting the screen again.
Okay, so now we can talk. Next slide. Next slide. So now we'll talk about the data set that we used for our project. So the data set we used was produced by a team from Spain. It consists of 1,238 multispectral images of single grapes, with each image having 37 bands of light wavelength. Each grape image has a grape type and a brix index. The five grape types are item 4, item 5, item 9, crimson, and autumn royal. So on the right side, you can see a small part of the CSV file which stores the grape type, the file name, and the brix index. Next slide, please. So we use multispectral images. What are multispectral images? So multispectral images are arrays of data that consists of image data in the form of individual arrays of light values varying by wavelength. These images are often used in the fields of medical, agriculture, environment, and military. It allows a better understanding of objects through an analysis of light wavelengths that are not even visible to the human eye. Our dataset consists of images that are stored in the form of NumPy arrays. The dimensions of each array is 140 by 200 by 37, meaning there are 37 images of each grape that are 140 pixels by 200 pixels in size. Next slide. So we also use the same multispectral image data in the form of RGB images. So in order to find the correct band for RGB, red, green, and blue, we needed to find the correct wavelength for all the colors. So the wavelength for red is 625.71 Newton meters, 488.38 Newton meters for blue, and 542.17 for green. With this information, we successfully recreated the actual images. So now the problem was to find the correct tuple of each band index referring a particular color once combined will give the actual color of the grape. Next slide. So here's a diagram of how we pre-process the data. So first we loaded the multispectral images and used NumPy for verifying the multispectral images for shape and number of bands. Then we sent it to CV2 to extracting the RGB bands, and then back to NumPy for normalizing and enhancing the RGB images, and finally CV2 for removing dirt via in painting. And then if we had to display it, we sent it to Matplotlib, or when if we were giving it to the model, we used TensorFlow. Next slide. So the methodology we used. So we approached the problem in two ways. So method one was using a single model that would give multiple outputs. So it's a multi-output convolutional neural network model. And the second method was using a classifier first, and then depending on the output, using a specific regression model. So we used various types of pre-designed and non-pre-designed models to train our data and test them. We also performed the tests using RGB images to see if the results were better. Next slide. So here's a quick architect diagram to understand the architecture. So we have five major models. That's ResNet 50, DenseNet 121, Inception v3, Exception, and MobileNet v2. These are all pre-designed architectures. So first we train them on multispectral images, and the output would be fruit type and brix index, and we'd repeat the whole process with RGB images. Next slide. We did the same thing for non-pre-designed architectures that are MLP and MSR3D-CNN, and these would give the same outputs, fruit type and brix index. Next slide. So let's understand a couple of models. So first we have the MSR3D-CNN. So the MSR3D-CNN, in full form multi-scale residual 3D convolutional neural network, is our custom architecture built for 3D multispectral data using PyTorch. This model is often used in the medical field to analyze and use multispectral image data. It uses 3D convolutions to extract both spatial and spectral features across 37 wavelength bands. It uses residual connections, help avoid vanishing gradients and improve training. Its multi-scale filters allow it to capture fine-grained as well as high-level patterns, and it achieved 100% accuracy for grape type classification and lowest ME/MSE for brix prediction. So ME and MSE are two metrics to compare models. Next slide. Then we have the MobileNet V2 model. MobileNet V2 is a fast and lightweight CNN optimized for efficiency without sacrificing performance. It's ideal for real-time grape quality prediction. So you can see a quick diagram of it. Next slide. Then lastly, we have the exception model. So exception stands for extreme inception and, and replaces inception modules with depth-wise separable convolutions. It is used using the TensorFlow library. It is capable of capturing rich feature representations while being more efficient than standard CNNs. It is particularly effective with RGB images where spatial patterns matter more. It utilizes channel-wise filtering, enabling better focus on individual feature maps, and it naturally avoids overfitting on small data sets due to parameter efficiency. And lastly, it scales well with deeper architectures without introducing unnecessary complexity. Next slide. Next slide, please. So going back to method one. So our previous slide. So our first approach was to we trained our models that would give multiple outputs. In our case, the grape type and brix index. So what are the benefits of this type of model? So first, it can use shared learning where it learns common features useful for both regression and classification, leading to reduced redundancy. It also has lower memory usage, faster inference time, and potential performance boost. On the other hand, it has a couple of drawbacks. First, that the model has to balance between two different types of objectives, that is, classification and regression. And if one dominates the other may suffer. One of the classification or regression can also underfit or overfit due to difference in complexity. And lastly, it can be difficult to debug as individual tasks cannot be fine-tuned. Next slide.
So now we talk about method 2. So in method 2, we use a rather complex method to do the same predict grape type and then predict brix index. So we basically optimize the grape type to predict grape index. So in our second approach, we designed another model architecture where it would first predict the grape type, and depending on the recognized type, it would go through five different types of regression models. So we have atom 4, atom 5, atom 9, crimson, and autumn royale. So first, we like as input we put a grape image, And for a CNN model such as MobileNet, it basically extracts its feature and converts it into a feature vector. Then it basically predicts the grape type. And based on the grape type, we use five types of regression models to predict the brix index. Next slide, please. So there are some benefits and setbacks for method 2. So the benefits are different grapes have different colors and textures, making it distinct models. So making distinct model will increase the accuracy since there are considerable changes in texture, color, and other features. And there are also some drawbacks of this particular technique. So while training models for each type, the data set had to be divided into five parts. So while we were dividing the data set into five parts, it caused data scarcity, which led to a lack in accuracy. Next slide, please. So these are the results for method one. So as you can see, we just use the best models. And here we can see that MSR3D is the best model. It has 100% accuracy. And it also has the minimal validation MEE and validation MSE. Next slide, please. And these are the results for method 2. And here also MSR3D is the best performer. It has 100% validation accuracy. Next slide, please. So these are the results for individual brix prediction models. So in the left side, you can see model performance for RGB images, and the right side, you can see model performance for multiple images. So in this particular case, MobileNet version 2 was the best performer because we can train it on more epochs and it is lightweight to, yeah, next slide. So for now we understand the results. The experiments and comparisons are between both the methods and also between both types of images, multispectral and RGB. The tables clearly show that multispectral images are the best data type for this project. This is because they capture more wavelength and provide more data for training. The validation ME decreases almost by 1 while using multispectral, and the validation R2 is very close to 0, making it the better data set. Now for method 1, for this method, which is the multi-output model, the best model is MSR3D It gives 100% accuracy. And for the classification task, it also gives 100% accuracy, hence outperforming all other models. And for the regression task, where it had to basically predict the bricks, it had the lowest validation ME and also the MSE. And for method 2, this method uses a more complex logic to predict the bricks and type. So therefore, heavy models like MSR3D can take more time and training time. And it can also crash our computers. So the best choice for method 2 is MobileNet version 2, since it can be trained on more number of epochs and it's lightweight. Also, MobileNet version 2, an exception, were the best performing model for this particular method. Next slide, please. So now we wanted to use numerical data. So previously we used the type of the grape. So now we are using basically the anthocyanin of grapes, which is the water soluble fruit content. So the idea is first we'll use a simple CNN, for example, sequential or MobileNet version 2, to basically predict the anthocyanin. And based on the anthocyanin and a regression curve, we will predict the bricks. So we use different kind of regression models. For example, we used LOS, used polynomial regression for multiple degrees, used random forest and other models, and we compared their metrics to see which model was performing best. Next slide, please. So this is basically the math of polynomial regression. So in polynomial regression, our goal is to find the regression curve of the following form of polynomial. So the polynomial can be written as the following, and the first is predicted. The first vector is the y vector, which contains the actual values of the anthocyanins. The second matrix is the design matrix, which contains all the exponents of xi's, and then it is multiplied by the vector of coefficients, which is the beta vector, which we need to find, and then the error vector is added to compromise any error. The above equation can also be written in the following form in pure matrix notation. And then using the ordinary least square estimation, we can find the vector, the beta vector, containing all the coefficients of xi's. Hence, we can find the regression curve. So this is basically what is happening in the regression task. Next slide. So here we compared the results of four regression models: polynomial, SVR, LOS, and random forest. So polynomial regression of degree 2 and 3 are the best performer in this case. Next slide, please. And this is for multispectral images. The previous one was for RGB images, but here we have, I guess, yeah, SVR is the best performer because it has the lowest validation ME and also MSC. Next slide, please. So this is the result for the regression model. So the overall best model is SVR since it has the minimal MAE and MSC, and we're not considering the data set we're using. So the overall best model is SVR. And then if we used RGB data set, the best models are polynomial regression of degree 2 and polynomial regression of degree 3. And then for spectral images, the best models are SVR and LOS with the bandwidth 0.2. So multiple images were once again the best data set. For RGB data set, the polynomial regressions were the best candidate. For multiple images, the SVR was the best model. So overall, SVR performed the best without taking into account the data set that was used. So and it also attained minimal MAE and MSC. Next slide, please.
So further ideas. So here's how you can implement this type of model in a factory. So first you can load the multispectral images of the fruits and vegetables, and you can also train it with a object detection model such as YOLO by Ultralytics. Then you can connect a camera near a conveyor to take photos of the food, and then load the object detection model to identify and extract images of each and every food item on the conveyor. You can then load the extracted images into the trained taste detection model and use the predicted values such as brix index to identify the unwanted food items. And then by the use of machinery, you can separate the unwanted food items on the conveyor. Next slide. So this is just a citing of all the works and all the references we used. Next slide. Thank you.
So that was a wonderful presentation. So this really demonstrates the growing convergence between machine learning and sensory analysis. So this will have potential implications of not only on food technology, but rather, I guess, healthcare, consumer experience design as well. So, anyways, you guys keep working on the paper that you have started writing on. Try to document it as quickly as possible, and see where we can go after that. Okay. And for the questions, you can leave comments on the YouTube or reach out to the presenters. So, thank you, everyone. Thank you, Gahan and Nishanth.
Thank you.